Imagine sending a digital message across the vast internet. How does it always find its destination, even with millions of possible paths? It is like a super efficient mail sorting system for every piece of data. The answer lies in a fundamental routing principle called Longest Prefix Match, or LPM. This rule dictates how routers efficiently determine the most specific and accurate path for every data packet, ensuring your information gets to exactly where it needs to go. Without LPM, internet routing would be chaotic and incredibly inefficient. The core mechanism behind LPM relies on the hierarchical structure of Internet Protocol, or IP, addresses. Each router maintains a routing table filled with network prefixes, which are essentially network addresses combined with a subnet mask. When a router receives a packet, it extracts the destination IP address. It then compares this destination address against all the network prefixes stored in its routing table. The key here is to find the longest matching prefix. For instance, if a router has entries for a broader network like 192.168.0.0/16 and a more specific subnetwork like 192.168.1.0/24, and the packet is destined for 192.168.1.10, the router will choose the /20 for prefix. This is because the 20 for bit prefix is longer and, therefore, a more specific match than the 16-bit prefix. This emphasis on specificity ensures that packets are directed to the most precise network segment, preventing misdirection and optimizing path selection. Practically, this means LPM makes routing decisions incredibly fast and deterministic. It is a cornerstone of efficient network aggregation, which greatly reduces the overall size of routing tables that individual routers need to maintain. By grouping smaller networks into larger summary routes, routers do not need to store every single individual network, but rather a more general route that points towards those smaller networks. Then, when traffic arrives for a specific destination within that aggregated block, LPM kicks in to find the most specific path among the available options. This also allows network administrators to exert more granular control over traffic flow, directing specific types of traffic or traffic to particular subnetworks through preferred paths. An essential enabling technology for LPM is classless interdomain routing, or CIDR, introduced to overcome the limitations of the older class-based IP addressing. CIDR allows 4 variable length subnet masks. This flexibility is precisely what makes Longest Prefix Match so powerful, as it allows network prefixes to be of different lengths, from short, broad prefixes representing large networks, to longer, more specific prefixes for smaller subnetworks. This intelligent design optimizes both the processing load on individual routers and manages the exponential growth of the global routing table. Without CIDR and LPM working together, the Internet as we know it today simply would not be able to scale. Ultimately, Longest Prefix Match is for more than just a technical rule. It is a fundamental principle that ensures data travels the most precise and optimal path across the global Internet. It is the invisible force that makes the Internet reliable, efficient, and incredibly scalable, connecting billions of devices and enabling our digital world to function seamlessly.
If you love understanding how the web works, like, subscribe, and stay connected with us.